In this lecture, we're going to look at atomic orbitals and how they relate to the periodic table. Remember that electrons can be considered both as particles and as waves. And as such, we are going to treat them sort of like mathematical functions because Ernest Schrödinger treated them as mathematical functions to come up with the atomic orbitals. So these are how the electrons are most likely to be found in space. Remember that the actual location of an electron cannot be determined and the velocity of the electron known. So we kind of just figure out where they could be in space. And we look at these electron orbitals, and each of them can be filled with a certain number of electrons. So each possible orbital can be filled by 2 electrons, and each energy level is going to have a different number of orbitals. So first off is energy level 1. Energy level 1 has a single s orbital, and energy level 1 is full when there are 2 electrons in that s orbital. Energy level 2 has 1 s orbital and 1 p orbital. Electrons will fill the s orbital, and then electrons will fill the p orbital. There are 3 separate p orbitals, each of which can hold 2 electrons. So you have 2 plus 2 plus 2 for your p orbitals, and 2 for your s orbitals, for a total of 8 in your second energy level. Now, when an atom is going to be filling its second energy level, that's only after it fills its first energy level. So anything with higher than 2 electrons is going to start filling its second energy level after filling its first energy level. And then we've got the energy level 3. This is where you're going to have 2 electrons can fit in the s orbital, 2 electrons can fit in each of the 3 p orbitals, and 2 electrons can fit in each of the 5 d orbitals. That's going to make for a total of 18 electrons can fit in energy level 3. Energy level 4 has 1 s orbital, 3 p orbitals, 5 d orbitals, and 7 f orbitals. 2 electrons can fit in each one of those. So we're going to have a total of 32 electrons that can fit in energy level 4. Now, it is quite normal to find energy levels that do not have all orbitals filled. So we're going to see in which order they are going to fill. And we're going to largely be doing that in the next topic, but let's take a look at this on the periodic table. For energy level 1, you have sublevel S, and then there's 1 orbital in that level, meaning total possible occupying electrons are 2. So this can be hydrogen has 1 in its s orbital, and helium has 2 in its s orbital. So you have a total of 2 electrons filling the s orbital. Now for energy level 2, after filling energy level 1, lithium will go on and put 1 electron in its s orbital. Beryllium has 2 electrons, so it'll put 2 electrons in its s orbital. And after that, you begin filling the 2p orbital with electrons until you fill that up at neon, which has 6 electrons in its p orbitals, 2 electrons in its 2s orbital, and 2 electrons in its 1s orbital, for a total of 10 electrons. Then we're going to move on to the next level, and they're going to start filling 3s and then fill 3p. At energy level 4, you fill 4s, and this is an interesting thing we're going to cover in the next part of the chapter. You actually fill 3d before filling 4p. So these metals are going to have the d orbitals being filled before filling the p orbitals of the lower level. And to make things a little more complicated, and we're not going to look a lot into this, when you start filling the f orbitals, you actually fill them in the order s, f, d, p. And you're going to fill these electrons into these orbitals. We're going to be doing that as we study the next topic, which is electron arrangement in atoms. But this periodic table tells you in which electron orbital is the outermost electron. So for your alkali and alkali earth metals, you have them in the s orbital. For your metals, you're going to have them in the d orbital. For your transition metals, the outermost electron is in the f orbital. And for these guys, these metalloids, noble gases, and halogens are all going to have your outermost electron in the p orbital. So where the outermost electron is determines where an element is on the periodic table.